It is not only one object which will be moving on its own, but there should be some external force which is acting. You might have observed this concept, that is, you might have experienced it too. Whenever you travel in a bus, what happens? Suddenly a brake is being put, but you will be at the state of rest, correct? It is directly proportional to the force, means as the force changes, force increases or decreases, it directly affects the momentum. If the force increases, momentum increases. If the force decreases, momentum is also said to be decreased. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to session 1 of chapter 5, Law of Motion. So, what are we going to study here? First of all, when the concept law of motion comes to your mind, we have to think about it properly in a manner of what is responsible for a motion. You can see nearly in our surroundings, in our neighborhood, there are many objects which have a movement, okay? That movement is termed as a motion. And what is responsible for that motion? And do we really possess certain motion which actually related to science? Yes. Each and every concept in whatever we are undergoing has got certain amount of science in it, right? So it can be physics, it can be chemistry, it can be bio, it includes each and everything whatever we study, correct? So laws of motion in the sense, the object has a movement, but we study what is the cause for that movement and how exactly the movement is caused and how exactly the movement is happening at what interval of time. All these concepts related to motion we study over here in a chapter called as laws of motion. So we can see here the pictures, there is a motion, different organisms possessing different motion. So we study, so the nature produces different types of motion. So what is its cause? At what time interval it is moving? Its time interval. And there are such rules and regulations. By looking at this, there are such rules and regulations which has been followed also. Those rules and those laws are being studied over here. So we study all these concepts under the chapter called as laws of motion. We study its laws. Okay, so in this slide you can see a boy is pushing a wheel as well as a box which is placed on that wheel over there. So here we can see the movement of the boy, the friction which is caused by the floor, as well as the rolling motion of those wheels and the movement or the static position of an object upon the wheel. Okay, so this is all what we can study here or we can see here. So here we can see a projectile motion which we had studied in motion in a plane, right? So we can learn about friction, we can study about projectile, what sort of motion it is, we can study about the movement or the rolling motion. All these concepts we study under this chapter called as laws of motion. So it's a package of the complete thing, that concept which involves something which is related to motion we study here. Okay. So now laws of motion. First of all, Aristotle, he held the view that the body is moving. Yes, obviously everyone will know that the body is moving, right? But something external forces required to keep a body in motion. Okay, so it's obvious that it is not only one object which will be moving on its own, but there should be some external force which is acting. It may be object, it may be the same kind of object, or it may be some other material or a substance or a thing which exerts certain force on an object so that it starts moving. So an external force is required to keep a body in motion. So this, what is required? Mainly the force is required for a body to keep any object or a substance under motion. That idea or the concept was taken out and put forth by Aristotle. His view was, if a body is moving, there should be some external force for it to move that particular body. So now, law of inertia was considered due to that concept. Okay, let us see how exactly the law of inertia was considered. As you can see in this image, one is inclined. You can see all the inclined planes and the straight plane. Here also you can see the inclination, both the sides. They are inclined one side. Here both the sides it's been inclined. Inclination means raising from the ground level to certain angle theta. Okay, that is called as inclination. So you can see, consider motion of an object on an inclined plane. Okay, so inclined plane, motion of an object. The ball is rolling downwards, rolling upwards, rolling straight. You can see all the images over here, right? So moving down an inclined plane, it's moving down so that its velocity is increasing. When the velocity of the object increases, what happens? It changes. Velocity keeps on changing, which means to say, as the velocity changes, what is that accounted as? It is accounted as acceleration. So you can say that the moving down body, when it is moving down an inclined plane, it is said to be accelerated. Okay. Suppose if a body is allowed to move up of the inclined plane, which is inclined at an angle theta again, then moving up, any object which is moving up can be called as retardation. It is undergoing retardation. That means its velocity is changing in a decreased manner. That is why it is called as retardation. And motion in a horizontal plane. So you can see, as you move the body, it moves. Till where it moves? It doesn't move till infinite distance. It moves until and unless some force is there for it to stop. A particular interval of time it will move and finally it will stop. And that stopping concept is only due to a concept called as inertia, due to the friction caused. The ball continues to move till where it moves? Till it is stopped by the friction which is caused in an opposite direction by this floor. Okay. Similar way, you can see the same thing is happening here. Any ball starting from certain distance, when it has both the sides also same inclined distance, it moves to the same distance. It is of the equal height as well as the distance covered also is fine. Now, secondly, when a inclined plane is a slightly bent towards that side, as you can see in this image, as you drop a ball from here, it reaches up to the same height but a longer distance it takes. And suppose if it is one single inclined plane, it is made to roll. That is, the ball is made to roll on an inclined plane. It moves unless and until there is a force which is acting against that object, and finally it will stop at the end. So all these concepts are put under a concept called as law of inertia. So I hope you have got the idea how exactly the object which rolls acts in case of inclined plane, singly inclined plane, as well as doubly inclined plane. And by this, let us just discuss what is inertia. Inertia is a very simple thing. As you can see in this image, you might have observed this concept. That is, you might have experienced it too. Whenever you travel in a bus, what happens? Suddenly a brake is being put, but you will be at the state of rest. Correct? You will be standing. With respect to object, that is with respect to the bus, you will be in the state of rest. When the bus suddenly puts a brake, you suddenly confront and fall, as you can see over here. That means you are an object. Okay, an object will be at the state of rest until an external force is acted upon it. That means you are at rest until the force is exerted by the bus on you. Okay, so that concept is called as inertia. Until and unless certain force is exerted on you, you will be at the state of rest or in the uniform motion. Suppose if you are in the uniform motion, you keep on being in uniform motion until and unless an external force is coming and disturbing you, right? So that concept you can study over here. So what is meant by inertia? Inertia means you are at a state of rest, being at a state of rest until an external force is acted on a substance or a object. It can be anything. Okay, so that is called as law of inertia. So coming to the next concept, having this law of inertia into account, there was a concept which actually took birth, and that concept is nothing but Newton's first law of motion, which is same as that of law of inertia we had studied previously. So let us just know what is Newton's first law of motion tells. So it's Newton's first law of motion is what we are studying. It is also known as law of inertia because it contains the concept of inertia, whatever we had studied in the previous slide. So every body is said to be, it continues to be at a state of rest or of uniform motion. Till when? It will be in a straight line unless an external force is compelled on that object. So again, let us come again. Every body, either it will continue to be at the state of rest or it will be at the uniform motion. Until when? Until an external force is acted upon it or compelled on it. That is called as Newton's first law of motion, which is also called as law of inertia. So you can see here there is a ball which is kept at the first step. The second step, an external force, that is a boy is kicking it, an external force is compelled on this object, and finally it gets a motion, a different type of motion, a ball is moving. So this actually holds good for Newton's first law of motion, which is also called as law of inertia. Why is it called as law of inertia? Because law of inertia also tells that being at a state of rest till when? Until an external force is acting on it. Even you can modify it as being at a state of uniform motion. Until when? Until an external force is compelled on it. Okay, that is what your first law of motion tells you. Okay, next is, let us study Newton's second law of motion. So there are three laws which we are studying here. Newton's first law, Newton's second law, Newton's third law. So now let us come into Newton's second law of motion. So what exactly the Newton's second law of motion tells you? Rate of change of momentum of an object. Okay, the rate of change of momentum. Momentum means it's a product of, so it is completely with respect to momentum. So momentum is, it's a product of mass into velocity. Okay, it's a vector quantity and we have velocity as a vector quantity. So this equation is said to be balanced. Okay, momentum means it is the concept of imparting velocity to any of the object. Okay, so now let us read. The rate of change of momentum of an object is directly proportional to the force applied. That means how much ever force you apply, those much amount of momentum is being seen. What is momentum? It is the way of imparting the velocity to an object. Okay, object with certain mass. So momentum can be given in terms of equation as momentum is equal to mass into velocity. So that is about momentum. So once again, let's read it. The rate of change of momentum. How does it change? It is directly proportional to the force. Means as the force changes, force increases or decreases, it directly affects the momentum. If the force increases, momentum increases. If the force decreases, momentum is also said to be decreased. Okay. So the rate of change of momentum of an object is directly proportional to the force applied and it takes place in the direction while the force acts. Wherever the force is acting, that direction only it takes place. So how is it given? Rate of change of momentum. Rate of change of momentum is directly proportional to the force which is applied. So the rate of change of momentum is always with respect to time. Okay, so writing this we have removing proportionality constant, let us just interchange. Force is directly proportional to the rate of change of momentum. So we have F is equal to K into dP by dt. So how do you equate this? So we have F is equal to K is a constant, proportionality constant, retain as it is. dP by dt is d by dt of, what is P? Is a momentum, it's a vector quantity and momentum is m into v vector. So how exactly we can write this? K, since we can't differentiate d by dt of mass because differentiating mass is impossible because mass is a particular, that is a constant quantity. So mass constant can be taken out and you differentiate dv by dt. This is rate of change of velocity with respect to time. So F is equal to K into m. Rate of change of velocity with respect to time is mentioned as acceleration A and consider the proportionality constant to be unit value, that means 1. So we have F is equal to ma. So I hope you have come across this formula most of the times, which is very, very, very important formula. So that is all about your Newton's second law of motion. From your exam point of view, the statement with this concept is very much important. So you have to know what is momentum, how exactly this second law is termed, all these things, okay? So now let us jump to impulsive force. So what is an impulsive force? As you can see in this image, impulsive force means the large force which is acting for a short interval of time. Okay, so you can, by looking at this image itself, you can get to know which are the large forces actually we see. Okay, a large forces is acting for a shortest interval of time, which gives you certain momentum to that object. Okay, it produces finite change in the momentum. This is called as impulsive force. So now, along with this impulsive force, we have impulse of a force. Impulse of a force can be termed as it's a product of force and time. So we can say impulse of a force is nothing but the product of F into time, that is force into time. So writing this, we can get F is equal to ma is what we know. So m of v minus u by t can be the value for F. Apply the value for F in impulse of a force. So now substitute the value of F here. So we have Ft is equal to m of v minus u divided by t. M of v minus u divided by t is the value of F, and we have t, so t cancel. So what remains is mv minus mu. This is the impulse of the force. So you can equate impulse of a force as the change in momentum. You can consider impulse of a force as change in momentum. That's all about your impulsive force. Now let us go to Newton's third law of motion. How exactly this Newton's third law of motion is given? It states that, as you all know, it's very simple. To every action, there is equal and opposite reaction. A boat is rowing over here. So when you just row, you're putting the water backwards so that you can move forward. So to every action, your action is moving, pushing the water backwards is your action, for which you are moving forward. That means it is a reaction. So it's simple. To every action, there is equal and opposite reaction is your Newton's third law of motion. That means, suppose if there is a force A which has been kept, your reaction will be force of B which is equal, but it will be of negative because it is reacting opposite words. So this is about your Newton's third law of motion. So today in our class, we have studied how exactly the law of motion is being put up, and what are those laws of motion, like first law, second law, third law. All these concepts have come into account. That's all for today in our today's class. Let us all meet in the next class, next session, with the next session of the same chapter. Until then, have a good day. Thank you.